Here's how a stream cipher works. Let's say we use some seed and get a deterministic sequence of numbers k0, k1, k2, and so on through any ki. So anyone who has the seed can generate that same sequence of random numbers. And then we take our plain text message and break it up into pieces that are the same size as these k's. And we take the ith of those pieces and combine it with ki using some operation which produces a ciphertext element. It's going to be random looking because these ki's are random looking, as long as we pick an operation that preserves the randomness of that kith element. We also want an operation that we can reverse. And so that's why the operation that makes a stream cipher is XOR, exclusive OR. Just to remind you how exclusive OR works, if you look at it on an individual bit, then 0 exclusive OR 0 is 0, because neither of them are true, whereas 1 exclusive OR 1 is also 0 because both of them are true. But if only one of them is true, 1 XOR 0 or 0 XOR 1, then we get a 1 out. It's also commutative, so it doesn't matter which order we have the arguments to XOR. And also, if we only know the result and we want to map it backwards, like we need to do to get from the ciphertext back to the plaintext, it turns out that it's the same operation to go backwards. That is, XOR is its own inverse. Another nice property is that 0 combined with XOR always gives us the thing that we combined it with. And the flip side of that is, if we XOR anything with itself, then we always get 0 as the result. That's how it works on individual bits. If you have a number like 12 and 9 that you want to XOR, then think of them in their bit representations, perform the XOR on the individual bits, and then take this result, where we did 0 XOR 1 is 1, 0 XOR 0 is 0, and so on, and reinterpret those as a binary encoding. So 12 XOR 9 is 5, and also 5 XOR 9 is 12, and 5 XOR 12 is 9, and so on. So that is why XOR is a handy operation. It mixes the random number with any other number, and because the individual bits are all random in that random number, it individually randomizes all of the bits in the plaintext. And since XOR is its own inverse, when we want to get the plaintext back from the ciphertext, all we need is to be able to generate that same sequence of random numbers, and we XOR them back using the same operation that we used to go from plaintext to ciphertext. Instead of just thinking about individual elements like this, I'm going to write ciphertext equals plaintext XOR k, where I really mean the ith ciphertext element is the ith plaintext element combined with the ith random number.